Very good morning to all. I'm Sathish Kumar, Assistant Professor in AIML Department in RMD Engineering College. I'm handling a subject Digital Principles and Computer Architecture. In Unit 1, Digital Fundamentals, we're going to discuss about number system in this session. We know that number system plays a vital role in digital environment, mainly used for to communicate with each system, as well as it used to in memory representations in number system. This number system are broadly classified into four types: decimal number system, binary number system, octal number system, and hexadecimal number system. Each number system has its own base. So in decimal number system, its base is 10, and binary number system base is 2, octal number system base is 8, and hexadecimal number is base is 16. As well as as well as in base 10 in decimal number system, the number varies from 0 to 9. In binary number system, base 2 number is either zeros or ones. In octal number system, base is 8, number range starts from 0 to 7. In hexadecimal number, base is 16, its number starts from range 0 to 15. In decimal numbers, it represented from 0 to 9. After that, 10 to 15, it represented in alphabetics. That means 10 represent A, 11 represent B, 12 represent C, and so on up to F. Let me see one by one. In decimal number system, we have 10 digits and base we say as a 10. In this, maximum value is digit 9 and minimum value is 0. In this decimal number system, represent a specific power of base 10. Example, we have shown that 21 base 10. Let we see the representations of it. In decimal number system, in this slide we shown the examples 5678.9. That means generally we can say decimal numbers 5678. Like this, it represented in the form of 5 into 10 to the power of 3, 6 into 10 to the power of 2, plus 7 into 10 to the power of 1, plus 8 into 10 to the power of 0, plus 9 into 10 to the power of minus 1. So in this case, 9 into 10 to the power of minus 1, which indicates fractional part. After the radix point, we say as it is a fractional part. That's why you represented in this. After radix part, we say as 10 to the power of minus 1, minus 2, and keep on going. Before the radix part, we say 10 to the power of 0, 10 to the power of 1, and 10 to the power of 2, so on. So in LSP represent negative symbol and MST represent positive symbol. This is the general representation of decimal number system. Next we see next type, binary number system. In binary number system, we have 2 digit only, either 0 or 1, so that its base is 2, and each digit we called as a bit, as well as a group of 4 bits we called as a nipple, as well as a group of 8 bits we called as a byte. So let me see how it represented. In this case, as a decimal, it represents base is 10. In binary, base is 2. Only we have 2 digits, so that its base is 0. So radix point come here. Before the radix point, we have 2 to the power of 0, and 2 to the power of 1, and 2 to the power of 2, and so on. After the radix point, it represents 2 to the power of minus 1 and 2 to the power of minus 2, which is very similar to decimal, but here base is 2. So in this case, negative symbol represent LSB, as well as positive symbol here represent MSB. Next we move for octal number system. In octal number system, we use 8 digits, right? It is very similar to decimal, but here coefficient is 8 digits. So number represented from 0 to 7, and it will base will be a 8. Same way, before radix point, we represent 8 to the power of 0 and 8 to the power of 1 and 8 to the power of 2, so on, which indicates MSD side. After radix point, we represent 8 to the power of minus 1 and 8 to the power of minus 2, which so on, which indicates LSD side. In hexadecimal, we have 16 digits, but in this case, in decimal they represent 0 to 9, as well as alphabet is represented from A to F, which indicates 10 to 15. Here, the position of each digit in hexadecimal number represent a specific power of base 16. So far we have seen various type of decimal number systems, various type of number system, such as decimal number system, binary number system, octal number system, and hexadecimal number system. Let's see the conversions, how decimal number converted to binary. How, let me see it in this slide. So in this slide, describe about how decimal number system is converted to binary. In this example is given 13 is the decimal number. We can convert into binary by dividing by 2, because binary radix is 2 or base is 2. So when you divide it, we obtain 6 here, and remainder is 1, as well as this 6 will be divided by 2, then we obtain by 3, remainder is 0. 3 divided by 2, we obtain the 1, and 1 divided by 2 is 0. Based upon the remainder, we move from LSB to MSB. So we obtained that values binary is 1101. This is the conversions from decimal to binary number system. Next we are going to see the another example how binary number system has been converted to decimal number system. Suppose the given binary number is 10101. So this can we going to convert into decimal number system. So in this case, we have considered as 3 steps. In first step, we return the binary numbers. As I said before, we don't have any point here, so that before the point we use power 2 to the power of 0. In case of we move from here, we are going to move to MSB side, so that take this 1 into 2 to the power of 0, and another is 0 into 2 to the power of 1. Another number digit is 1 into 2 to the power of 2. Another digit is 0 into 2 to the power of 3. Another digit is 1 into 2 to the power of 4. So based upon the power, we multiply it, and multiplying the respective numbers, we obtain the value 160401. Finally, we add all together, and we obtain the values 21 this 10. So in this session, we have seen about what is the number system and what are the type of number systems, and finally how converting from decimal to binary, and similarly binary to decimal. Same way, based upon the base, we go base varies, we going to convert octal to decimal, as well as decimal to octal, decimal to hexadecimal, and hexadecimal to binary, so on. This is the basic steps for converting. That we see in next session, remaining various conversions. Thank you.